Alright, the first couple examples here aren't really counted as examples, so I'm going to go ahead and make the video for these two things plus example 22.1, so if you go back to watch the video and you need to see stuff about this, just know example 22.1 is where it's all going to be. Numerical and algebraic expressions. A numerical expression is a meaningful arrangement of numerals and symbols that designate specific operations. Numerals being numbers and symbols like plus, minus, times, divided by. Alright? An algebraic expression is a numerical expression or an expression that contains variables. Okay, so an algebraic expression is a numerical expression in addition to having variables. So any numerical expression is also algebraic officially, but if we're going to distinguish between the two, let's just say they're either numerical or they're algebraic, not both. Alright, so if you look at the first one here, 4 times 2 plus 3. Everything's numbers, right? We got symbols, parentheses, a plus sign. There's multiplication implied by the fact that 4 is next to the parentheses. This is a numerical expression. Looking at the second one, x plus 4 contains a number, right? But it also contains a variable. That makes it an algebraic expression. I am not an English teacher, but I do care about spelling. There's this word going around in the world, algebraic, that people occasionally use. I don't know if they heard it somewhere from somebody. Maybe you just heard it from me the first time ever right now. It's not a word. Algebraic is the word you're looking for. It's algebraic. How some of you think about algebra, I'm sure. Ick. Yeah, right. But algebraic that's how it's spelled without the K on the ick. But anyway, algebraic, that's how you spell it. Please try and spell things correctly whenever possible. What about this third one here?
That'd be numerical.
Very good. Everything's numbers. There's no letters, so it's numerical.
The other one would be algebraic.
Very good. This is going to be algebraic again because there's an X in it.
And not algebraic.
And not algebraic, but algebraic. X squared minus, as long as there's a variable, it's algebraic. If there's all numbers, it's numeric or numerical. So those are the types of expressions we're going to deal with. Numerical expressions can be evaluated as is. Algebraic expressions can only be evaluated if you know the value of the variables. All right. And we move on to the next group of things here. Statements and sentences. This tells me to use n subscript p to represent the number of peaches, and n subscript a to represent the number of apples. All right? What's going to happen a lot of times in this class, we're going to do word problems. That's coming up very shortly. And you're going to have something in your word problem that you don't know, such as the number of peaches or number of apples. And you're going to use a variable to represent what you don't know to give it an answer. So in this case, if I say, hey, how many peaches are there? The correct answer is n sub p. Because for right now, that's what we're calling the number of peaches. If I say how many apples there are there, you'd say n sub a, because that's how many apples are there. All right? I typically use a single letter to represent. The book likes to use subscriptive variables quite often. I could have just as easily said a for apples, p for peaches. All right? But you use a variable to represent things you don't know. And then through algebra, you can find out what those letters equal numerically, and then you have the answer. All right? And one step in word problems that's going to be necessary to be able to get a word problem solved is to be able to write an equation using variables to represent things you don't know. So this first statement says the number of peaches. How many peaches are there?
We don't know.
What do we call it?
N sub p.
N sub p. Very good. And then the word equals, what do you think that does?
Equal sign.
Make an equal sign. Very good. And how many apples are there?
N sub a.
N sub a. So we have the capacity to translate words into an algebraic equation. All right. The problem with this is number of peaches doesn't have a translation, so we give it a translation. All right. Think about Spanish class. Imagine if you didn't know what a word was and you just invent some word that means the word you mean, and everybody knows what you're talking about. Wouldn't that be great?
Yeah.
I don't know how to say library. So instead of saying
Librario.
it's actually biblioteca is library. Yeah, that's what library is. Anyway, but you don't know that, so then you make up some word. You know, whatever. Just
Chicken.
what is? Instead of saying Chico. All right, Chico means library. Okay, and then if you say Chico, people know what you're talking about, even though Chico means boy. All right,
Oh.
but anyway. This right here has no translation mathematically, the number of peaches, so we invent a translation for it. This also has no translation, so we invent a translation. So that's kind of how word problems are going to work. We don't have a translation mathematically for a word, so we invent a translation. For the rest of the problem, this thing is going to be represented by this letter. So when that shows up, we have the ability to write an equation. All right, let's look at example of the second one here. The number of peaches. Again, no translation legally, but we created one. N sub p represents the number of peaches. What does not equal look like?
Equal sign and slash through it.
Equal slash through it. And then the number of apples. N sub a. All right. How about the number of peaches? That's N sub p. What is greater than looks like?
It's eating the peaches.
Eating the peaches. So it's going to be opening up towards the peaches. And that's going to be the number of apples. And finally the last one, number of peaches. That's N sub p. Is less than.
So it's eating the apple.
Now it's pointing at the peaches. Now it's eating the apples, right? Number of apples. Okay, those are all basic translations from words into algebraic expressions or equations, inequalities or whatever. But know that we're going to be entering into the world of word problems very shortly. They're going to start off with algebraic word problems that are just testing your ability to translate words into a good algebraic equation. We're going to move into specific types of word problems such as coin problems, uniform motion problems, ratio problems, percent problems, and there's different techniques for each of these, but most of them involve translating words into an algebraic equation. Get accustomed to the wording there, and as we continue on with the idea of word problems, it should hopefully sink in pretty well. Now moving on to example 1, the real meat and potatoes of this lesson. Example 22.1, does negative 2 or positive 5 satisfy the equation x squared minus 5x minus 6, or equals negative 5x minus 6? First off, when you're looking at an equation, the highest power in the equation represents the total number of answers possible. So the fact this is x to the second power means there's 2 answers possible, which means both answers might work. All right? When it says satisfy the equation, that means if I replace x with this number, the left-hand side and the right-hand side are equivalent to each other. They're the same number. If they aren't equal, that means it does not satisfy. So all I've got to do on a problem like this is test my answer. For x equals negative 2, I'm going to change the x's into negative 2's. Notice x is being squared, so parentheses squared to represent x squared. Negative 5x, so negative 5 parentheses x to represent negative 5 being multiplied by x. I'm going to put x equals negative 2 inside those parentheses. Always, when you substitute a letter with a number, make sure you put the sign and the number in a parentheses to establish that both the sign and the number are being raised to powers, multiplied, whatever. Negative 2 to the second power is going to equal positive 4. So again, it's very important that minus sign's in the parentheses to create that negative, or sorry, to create the positive from the 2 negatives. And then negative 5 and negative 2 make positive 10, right? That gets me 4 equals 4, which is a completely true statement, right?
Yep.
So that means that negative 2 satisfies the equation. That's the correct answer.
So you want us to just, what do you want us to circle? That's it.
Yeah, I'm going to include 5 also if it works. I'm going to say negative 2, comma 5 work, or negative 2 works. All right, so whichever ones work or works, I'm going to put those numbers and say they work. Yes?
Can I circle both of them and say, let's say negative 2 doesn't, and, well, let's say negative 2 doesn't and 5 does, and can I say, circle both of them and say 2 doesn't, but 5 does?
Just tell me which one works.
Alright.
Just tell me. So I'm going to assume you test both. If they both work, fine, right? They both work. If only one works, just tell me which one works. So we know for a fact negative 2 works because it just worked, right? 4 equals 4. All right, now if we try positive 5, and again, our equation is x squared is supposed to equal negative 5 times x minus 6. Again, putting parentheses in place of my x's, I'm going to replace each of the parentheses with a positive 5. The positive sign is not really required to be written there, right? I don't have to put plus 5. So 5 squared is 25. Negative 5 times 5 is negative 25 minus 6. So 25 is equal to negative 31. That's not true, is it? So 5 doesn't work. So negative 2 works. That's what I want your answer to look like. Tell me which ones work. And again, if they both work, negative 2 and 5 work. All right, in this case only negative 2 works, so tell me that one. Just so you know, negative 3 also would work on this one. They aren't always going to give you all the answers to it, but I did say that 2 answers were possible. If you try negative 3, we're going to get negative 3, the quantity squared, equals negative 5 times negative 3 minus 6. That's going to be 9. This is going to be 15 minus 6. 9 equals 9. See, negative 3 also works. So again, x to the second power can have up to 2 answers.
Positive 3 could work too.
3 wouldn't work because if we put positive 3, we're going to get 9. We're going to get
Oh,
negative
yeah.
15 minus 6. Yep. So only negative 2 and negative 3 will work on this one. But you don't have to find the other answer right now. Test the ones they ask you to test. If it works, fine. If it doesn't work, throw it out. And that's all we're looking for right now.